Anytime you have a problem where you're taking the limit as x approaches infinity, all you're going to do is you're going to look at the rational function that I'm applying this limit to. You're going to look at the degrees in the numerator and denominator. So here, degree in numerator would be 2 because that's the highest power of x present. Degree in denominator, also 2 because that's the highest power of x present. If I notice that the degrees are the same, and I compare to what I know about finding horizontal asymptotes, whenever the degrees are the same, I divide the coefficients on those x terms. Whatever I get back, in this case 3 divided by 5 get 3/5, that is simply going to be my limit. That's it. So if you're taking the limit as x approaches something infinite, we're looking at degrees in the numerator, we're looking at degrees in the denominator. Degree in the numerator this time, highest power of x is 1. Degree in denominator, the highest power of x, 2. We have a situation here where the degree in the numerator is less than the degree in the denominator. Based on what we know about our little shortcuts here for finding horizontal asymptotes, anytime the degree in the numerator is less than the degree in the denominator, our horizontal asymptote is 0. Therefore, as we evaluate this limit, our answer is simply 0. All right, another situation, limit as x approaches infinity, compare degrees in numerator to degrees in denominator. On this one, it should be obvious. Degree in denominator is 1, right? The top one's a little tricky in the fact that you've got a root applied to this expression. So when I look at this x squared right here, I have to understand that I've got a square root of x squared, right? That equals x, meaning my degree in the numerator is just 1. So I do apply that root to this term to understand what the degree is, and once I understand what the degree is, I see that degree in the numerator is the same as degree in the denominator, meaning I go back to the same shortcut I used on number 1, divide your coefficients. So if I divide my coefficients out, in the denominator coefficient was 3 on that term that helped me to figure out the degree. In the numerator, it would appear I've got a 2 as a coefficient, but remember that root is applied. So we're going to take the square root of 2, that's the numerator, and put that over 3. Square root of 2 over 3 would be my answer here. All right, you got a limit problem here, where the limit, you got x approaching infinity, but you're not applying it to a rational function. So one way to maybe look at this is, this expression right here, this function right here is all over 1. So you could say that degree in the numerator is 3, degree in denominator is actually 0. So degree in the numerator is greater than the degree in the denominator. That's one way to look at it. But since this is a unique situation where we don't have the degrees being equal, we don't have degree in the numerator less than degree in the denominator, I would graph this out. Let's go to the graph of this function. If x is approaching infinity and I graph this, I see how the function curve's going up here off the screen, coming back down, and going up off the screen again. If x is approaching infinity, that means x values are getting larger and larger and larger as I go out this direction. So if I'm traveling on the graph, going up, going down, going up again, right? So as the x values are getting larger, this graph continues to go up, right? So my limit here would be something infinite, be positive infinity. So just because it's interesting to note, you know, if this had been going in a negative direction, x is approaching negative infinity, then I go back to the graph. Let's see, the x value is getting smaller as I go this direction. So as I head this direction, I'd be traveling on the graph going this way, meaning graph would be going down, right? So my answer would be negative infinity if I was going the other direction.